Hello everyone. Let's continue our discussion on limits, and for today I'm going to focus on limit properties. So let's assume that we have two functions like f of x and g of x, and we know that the limits of these two functions exist when x approaching to a, and the limit of f of x when x approaching to a is L, and the limit of g of x when x is approaching to a is m. So we can have different rules actually based on limits and for limits. And the first one and the most fundamental one is the summation rule, which says that when we have the limit of two functions and the limit of these two functions already exist for one specific value, we can have actually the summation of these two functions. As you can see in here, limit of f of x plus g of x when x approaching to a, and the limit of that is going to be the summation of their individual limits. So we have the limit of f of x equals to L, we have the limit of x g of x when x approaching to a equals to m. Therefore their summation is going to be L plus m, their limits of summation. And we can have the same, almost the same principle for the difference rule, and here we have the subtraction. So we have the limit of f of x when x approaching to a equals to L, we have the limit of g of x when x approaching to a as m, therefore their difference is going to be L minus m, as you see here. And the third rule that we have is constant multiple rule. And constant multiple rule says, okay, again we have the limit of f of x when x approaching to a equals to L, and now we are multiplying a constant number to that specific function, and we want to find the limit at that specific value x, for here x approaching to a. So it is easily going to be k times L, and L is actually the limit of f of x when x approaching to a. The fifth one is the product rule, and for the product rule we have actually the multiplication of two functions, and again we know that for these two functions the limit exists when x approaching to a finite value, and here that finite value is a. Therefore because we know that the limit of f of x is L, the limit of g of x is m when x approaching to a, therefore the product rule says we have to multiply these two numbers so that the final value and the final answer is going to be L times m. And another one is the quotient rule. For the quotient rule, what we have f of x over g of x when and we are going to take the limit when x approaching to a, and we know that the limit of f of x again is L when x approaching to a, the limit of g of x is m when x approaching to m, therefore the answer is going to be L over m, and we have to know that m cannot be 0. And the very last rule that we have, actually we have the f of x now, the function f of x, and we want to actually use this function, and then this function is going to be powered by a real number, and here that real number is r. So f of x, the whole function to the power of r, and we know that the limit of f of x when x approaching to a is L. Therefore, when this function is going to be powered by a real number, the limit of that function is again going to be powered. So what we have in here, the limit of f of x when x approaching to a, we know that it is L, and now f of x is to the power of r, therefore its limit is going to be to the power of r, and at the end we will have L to the power of r. So we have seen 7 different basic properties of limits, and let's examine these properties with just one example to see how it works. So the example that we have here is combining somehow all of these rules together, and as you can see we have x squared, so I'm going to call this one as f of x, and then we have the summation rule as plus, as we can see, and we have sine of x plus cos x squared. So the sine x plus cos x is actually a function like gx, and gx is going to be a squared. So this is the power rule, and then again the summation rule, and finally we have the quotient rule. As you can see, x e to the power of x over x cubed plus 1, and this is going to be called, for me, is kx. And then we have a constant, we have actually the difference rule, negative sign here. So this is a difference rule, and finally a constant number times to a function, because we can call it qx. So this is going to be the actually qx, and this 3 that we have is a constant number. So in order to find the limits, we have different approaches, but the first thing that we have to actually do is just to plug in the value that we are approaching to it. So here the value is 2, and the only thing that we need to do is actually plug in 2 instead x. So it's going to be 3 squared plus, and then we would have sine 3, it is going to be 2 squared, and this is approaching to 2, it's going to be sine 2 plus cos 2 squared. So again, we have actually the summation rule. We would have e to the power of 2 plus 2 to the power of 3 plus 1, and then the difference rule, the negative sign, minus 3, and then just plug in 2 there. So the constant times the function is going to be 2 plus 2. So finally we have to find to calculate each of these terms. I'm not going to calculate each of these terms because it is not actually the main aim for this lecture. You can easily calculate it with your calculator. What I wanted to actually discuss with this example, most of the functions that we are dealing with is a combination of these different properties, and you have to use these different properties in different examples that you will see in our next lectures, in your assignments, in your exams, midterms, whatever you are dealing with, and there is a limit there. Thank you very much for watching this video. If you enjoyed, please subscribe our channel.